morning, everyone. My name is Dr. Naga Raju, working as Assistant Professor in the Department of CSE and ML in Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about a concept called as programming styles and techniques. We are going to especially concentrate on the programming styles and techniques on behalf of Prolog programming, which we use in order to develop artificial intelligence programs. So the topics we are going to cover in this particular session is the general principles of good programming. This is the first topic we will cover. Then later on, we will try to understand how to think about the Prolog programs and what is the programming style that we follow when while writing the program AI programs, and also we are going to see several problem solving techniques. So especially in these problem solving techniques, we are going to concentrate on the two different techniques. One is called as a depth first search and another depth first search, and another one is called as breadth first search. So in this particular case, we are going to take one example each, and we will try to understand how this depth first search and breadth first search will be implemented in order to solve certain AI related problems. So let us directly start with a concept called as the general principles of good programming. So how can we say that the principles whatever we are following means the method of writing the programs whatever we are following, that is correct or not. So for that particular thing, we need to understand the different principles. We can say even they are the general principles of good programming that we need to discuss here. So which principles are called as good programming principles? So in order to understand these good principles of a programming, we need to we need to be in a stage to extract the answers for the given questions here. So what is the first question? It is how to think about Prolog programs. So this is the first question we need to understand. Later on, what are the elements of good programming style in Prolog, and how to debug the Prolog programs, and how to make the Prolog programs more efficient. So we need to first of all about Prolog programs. So we need to think about these Prolog programs in the sense already we discussed in the earlier sessions also. The writing of other programming languages programs is entirely different with the writing of Prolog programs. So first of all, we need to understand how these Prolog programs will looks like. And later on, means we can say that the general structure what we follow to write the Prolog programs. And later on, we need to understand what are the different elements that we use in order to make a good programming style. And once we follow these two, and once we are ready with the Prolog program, then we should supposed to know how to debug those programs. And later on, we need to see whether the written program is so efficient or not. Means whether the program is giving the results what we have expected or not. Okay, so these are the four different questions for which we need to give the answers. Okay, then we can say that we are following the very good principles while writing the Prolog programs. So we will try to see each one one after another whenever there is suitable with suitable examples. So coming with the general principle. So what is a good program? So when can we say that? Means everybody can write a program, but we cannot say that which one is a good program. That's why we can say that there are different kinds of properties which that program need to be satisfied. So that's why when can we say that a particular program is a very good program? For that one, there are several criterias. We can say that there are some criterias, or there are some properties which a program need to be satisfied. Then only we can say that it is a very good program. So in this one, the first criteria is the correctness. First criteria is the correctness, which is nothing but a program should be correct. A program should be correct. So this word we can elaborate, we can discuss in different perspectives. So we can say that the program need to be correct in terms of syntax and semantics. Okay, it should be correct in terms of syntax and semantics, and at the same time it should be correct means it should be exactly similar to the it should match to the problem statement also. So then we can say that a program is correct. So this is one of the criteria, and in this particular piece means whenever we are trying to concentrate on this correctness, we are doing some kind of mistakes while writing the program. So we can say that the common mistake while writing the program is neglecting the criteria of the correctness. So what is the criteria that makes a program to be so correct? So that we are neglecting. But so why we are neglecting means by keeping attention on the efficiency. Means we write the program and we will try to extract the results, and we will try to see whether the results are giving the efficient outcome or not. So we can say that whether it is an optimal result or not. So our concentration will be always on finding the effectiveness, but we are not concentrating on the correctness of the program. So the correctness of the program is going to be based on the several criterias. So that criterias, first of all, we need to understand. Okay, so that means that every program whatever we write, that program need to be correct. Okay, need to be correct in terms of problem statement, in terms of semantics and syntax, in terms of the need, in terms of requirement, we can say, and at the same time it should be correct by giving the efficient result also. So the second one is efficiency. Okay, so I am saying that here based on the concentration on the efficiency, we are neglecting the correctness. So even though the correctness is considered more, but we should not neglect the efficiency. Why? Because efficiency of the program is also very, very important. That's why we can say when our program is so efficient, it can able to give optimal result for us. Okay, so it should not needlessly waste computer time. So when can we say that the program is so efficient? Means whenever we could able to save the time as well as the space. Coming to the third principle, which is called as transparency and readability. So this is also very, very important. So the program, so whatever the program we are writing, that program need to be very easy in order to read as well as in order to understand. Okay, so once we write the program in a easiest way, so it will be very easy to read. So when it makes us very easy to read, then obviously it will makes us understand very easily. Okay, so in the sense we need to concentrate here in the sense understanding is nothing but understanding the meaning of the program. Understand the meaning of the program in terms of two different things. One, we can say that declarative, and also the other one we can say it as procedural. Means we can say that a program is very much easy in read and easy to understand. That means that we are understanding the meaning, declarative and the procedural meaning of the program. So then we can say that the program is completely readable. Okay, and also whenever you follow the particular layout also, then it will makes us to understand the program very easily. Means it will makes the reading of a program easily, and also it will makes to understand each and every statement that we write in the program. So that's why we say that one of the principle is transparency and readability. Means, and once you follow the layout of a particular program, and if you keep on writing the different elements, then obviously it will makes a program to read easily. At the same time, it will makes us to understand easily. Next one is modifiability. So this is also very, very important. As we know that especially in artificial intelligence problems, that they are completely depend upon the knowledge base we are supplying to it. So means if the AI program is exhibiting certain kind of intelligence, that means that it completely depends on the knowledge we are giving to that program. So we cannot say that every time this knowledge is going to be stable, fixed. Okay, so based upon the problem statement and based upon different scenarios, we need to keep on updating the knowledge base. So once the means if your program is not in a stage to allow the modifications, it will be very difficult to update the knowledge base. So if you won't update the knowledge base, it cannot be given to the AI program to exhibit the intelligence. Okay, so that's why your program should be in a stage to modify very easily. Right, means whenever you think that the knowledge provided in the knowledge base is not matching to our problem statement, then we could be in a stage to modify it. At the same time, if you believe that the data knowledge you mentioned in the database is not so sufficient, and you need to add more knowledge to the database, then it should allow to extend it. So means we can discuss these points in two different two things. One is we can say that the modification and extension of the knowledge we are keeping in the knowledge base. At the same time, we can say that AI program means AI program can be modifiable. It need to be extendable. At the same time, the knowledge base also can be in a stage to get modified and also to get extended. So the next criteria, we can say that robustness. This is a other principle, right? What is that? Should not crash immediately. Means think that the user has given different inputs. For example, if there is some kind of text box, right? Of course, these kind of things will not be there in Prolog programs, but I'm giving certain kind of example. You have there is an input area where this input can take only numbers. But if the user is providing the alphabets, then what happens? It leads to the incorrect input. So in this case, in this particular case, your program should not get crashed. Your program should not get crashed, but it should be in a stage. Means your program should be in a stage. That means that it need to be alive. Means it cannot get terminated abnormally. So in this case, what your program has to do means even the user is giving the incorrect inputs, your program should supposed to give the errors. It need to report the errors. What errors it has been occurred, so that the user by understanding these errors, he can do the modification. He can provide the correct inputs. Coming to the documentation, so this is also very important. When it comes to any programming language, not only Prolog program, you can take Lisp and any other programming languages, documentation is very important. And wherever there is a requirement, there is a need, definitely you need to include some additional information about that program in the form of the comments. So that's why we can say that even the documentation is also very important. Why? Because we can say that comments are going to be helpful in order to have a quick reference of particular statements in the program. So even this will means even the comments, if you mention the comments in the program, it will make the user even to understand and read the program very easily. Now the question is how to think about Prolog programs. How to think about Prolog programs. So just now we discussed that whenever you want to understand the Prolog programs, first of all you need to understand the different meanings of the Prolog. So what are the different meanings? We are going to have two different meanings. One are called as declarative and another one is the procedural. So if you are thinking about a particular Prolog program, that means that you are thinking about the Prolog program in terms of declarative and in terms of procedural. So what the declarative is going to tell means it will tell clearly that what are the facts. What are the facts you have used and what are the outcomes you are going to get. Otherwise, we can say what are the facts and what are the rules you have mentioned in the program, and at the same time, what are the outputs it is going to give. When it comes to the procedural, it is going to talk about the concept called as how. Okay, means for example, think that here the declarative meaning of a program has given that some X is a output we are going to get. But we need to understand even the procedural meaning also. Procedural meaning in the sense how this X is going to be the output of the program. So that is nothing but here understanding the procedural meaning of a program. So if you want to think in terms of, if you want to think about Prolog programs, think in terms of what are the facts and rules you have included, and also what are the outputs it is going to give. At the same time, you need to think about how that Prolog program is giving a result as a value as a result. So we can say that these declarative solutions, especially, they are very easy to develop. They are very easy to develop, but when it comes to the efficiency, we cannot guarantee a very good efficiency with the declarative solutions. And next, develop a solution by finding the ideas of reducing problems to one or more easier sub-solutions. So this statement we can we can discuss very elaborately. What is that? One is develop a solution by finding the ideas of reducing the problems. Means whenever you think that the problem is too complex, then it should be you should decompose this problem into several parts, and we call them as the sub problems of the main problem. So what we have to do is we need to develop the solutions of the sub problems here. We need to develop the solutions for the sub problems, so that it will becomes very easy for us even to solve this complex problem also. And this will be one kind of case, and another kind of case is trying to extract all the possible solutions, and try to select the best one. So for example, think that you are trying to identify the shortest path between the given points. So in this case, what happens, first our concentration will be trying to extract the different paths that are available between the given points. So you are going to get some kind of solutions, but after that we are not going to consider all the solutions. Why? Because our concentration is on finding the shortest path. So in this case, the whatever the values we got from that values or from that solutions, we are going to select one which is giving the shortest path between the given points. So it should be in that particular state. And another good idea is to generalize the problem, original problem. Means AI problems, especially if you think about the AI problems, don't go for the specific one. Specific one means in the sense, for example, I will take one simple statement saying it as mother Sita Kama Gita. So this is a very common fact is there, common relation we can say. Okay, so in this relation, what happens? Sita is the mother of Gita. So this is the statement generally what we understand. But in this case, what happened? This became too specific. Means we are talking about the relationship between Sita and Gita. Means if your problem statement is to identify the relationship between Sita and Gita, then it will be fine. But here the one suggestion it is giving is try to generalize the statements. How? Means simply you make it as X and Y. So what happens in this case, whenever you mention X and Y, you can make use of this particular relation in order to show the relationship between the any two people. Okay, so we need to generalize the problem, original problem, and formulate the general solution recursively. Okay. Next, introduce some graphical representation. So this is very important. Okay, visualizing, we can say visualizing means what is visualizing or graphical representation is going to tell means how we are going to solve the problem. How we are going to solve the problem, especially when it comes to AI programs. What happens? Some state is given to you. Some state will be given to you, and your task is you need to move from the given state to the desired state. So this is a common statement that is given to all the AI programs, AI problems we can say. So in this case, right, given to decide. So what it is suggesting to have a graphical representation. So what this graphical representation is going to show us means it is going to visually show us how the given state is converted or moved to the desired state. Okay, so representing this graphical representation, even we can say that this is the state space. Even it is also called as a state space. Means representing the state space is nothing but here the representing the state space in the graphical way, so that it will be very easy. Means even a non-programmer also he could able to understand how the problem has been solved by seeing this visualization. Okay, so it is very important to have a graphical representation while solving some problems. Next, coming to the programming styles. So while writing the programs, we need to concentrate more on this. What is that? Why? Because there is a possibility of having more number of errors. So we can say that for a good programming, this is going to be one of the danger. So you need to concentrate, means you need to concentrate more in order to reduce the program errors. And also we discussed this point. What is that? To produce programs that are readable, easy to understand, and easy to debug and modify. Okay, so these points comes under the general principles of the programming. And coming to the rules, while writing the rules, how can we say that it is a very good programming style? Means when your clauses, means whatever the statements you are mentioning in the prologue program need to be very short. And you need to include few number of goals in each and every clause. Means you cannot keep all the rules in a single clause. So if it is the case, the complexity of the program is going to increase. So it will be very hard to read it. It will be very hard to understand, debug, as well as modify. So you try to keep few number of, means only less number of what we can say, less number of statements in a particular class. So procedures need to be short. So we can say that it is short and sweet will be the better one here. Okay, so name should indicate the meaning of relations and also the role of databases. Coming to the problem solving strategies. So we can say that the strategies are completely centered around a general scheme which is called as state space. So that's why we call it as a state space representation or a state space. So what do you mean by a state space? Means it is a graphical representation of showing a problem. So just now we have told, means in especially in AI programs, a given state will be given to you and it will be asked to move to the desired state. So by writing the program, means if you write a program, that program is easily understood by another programmer. But if the user is a non-programmer background, so in that particular case, only this graphical representation is going to help him in order to understand how the problem has been solved. So the problem solving strategy is nothing but first of all representing the state space. So we can say we can do this like this. So first we can describe the state space. Then after we can go for the visualization of the state space, which is nothing but a graphical representation. So in these graphs, what happens? There are going to be the nodes which are going to talk about the problem situations. So a given problem is reduced to find a path in this graph. So how the problem is going to be reduced? Problem is reduced in the sense trying to identify the solution for the given problem. So how we are doing by identifying a path. For example, you see this is the given state for us and this is a goal desired state. So in between there are some particular paths are there. Okay, so if we can able to identify this is a particular path, okay, identifying the particular path, that means that we try to get a solution of identifying the shortest path or the path in order to move from the given state to the desired state. Okay, so problem solving involves graph searching and typically leads to the problem of dealing with the alternatives. So in this case, what happened? We are having three different alternatives. Means we can able to find the path between the given state and the desired state. So one thing is we can easily identify or we can easily deal with the alternatives. So how many alternatives are there in order to move from the given state to the desired state? But if your problem is too specific, means identifying the optimized path, then we are going to look for the shortest path itself. So two basic strategies are there for exploring these alternatives. What is that? One is called as depth first search and another one is called as a breadth first search. So we will try to see this breadth first search and depth first search with examples. We will try to understand this one, a puzzle problem. So this problem is particularly defined as a state space. So just now we discussed every problem statement initially need to be represented or described in terms of the state space. If you are describing the state space, that means that you are giving a general explanation of the problem statement. Okay, if you are giving the visualization, that means that you are showing the complete picture of how the problem has converted into the solution. So our first primary duty is we need to define the state space. Nothing but here the start node. First we represent the start node. Then after we represent some goal conditions. And then after we present the goal nodes. So that's why I'm saying that in the graphical representation we are going to find the nodes. So what these nodes represents, either it can be a start node or it can be a goal node, right? Or it can be the nodes in between the start node and the goal nodes. So how it will be, you see, if you observe this particular picture, what happened? This is the given state to us. This is a 8 puzzle problem. In this there will be 8 questions. So we can say that it is a 8 by 8 matrix representation. In this we are going to have some kind of numbers and an empty tile. So totally 9 tiles will be there. In the 9 tiles, 8 tiles will be filled with some numbers and there will be one empty tile. So what you have to do is we need to make use of this empty tile. Okay, we need to make use of this empty tile and we have to rearrange these numbers. So finally, what is our desired state? Means we need to rearrange the numbers in this particular way. So that's why I'm telling that most of the AI problems are related like this only. State will be given to you and you will be asked to move to the desired state. Here the question comes is, how can we move from the given state to the goal state? So in this case, we need to understand the first goal conditions. So what are the conditions we are having? Conditions in the sense we can say that what are the legal moves we are having. What are the legal moves we can do, we can perform here. So we know that the legal means for every move in the 8 puzzle problem, there are 4 different legal moves. Either you can move top, or you can move down, or you can move bottom. Okay, sorry, it is down only, so we can say it is left, or it can be right. So these are the 4 possible moves we are having. So in this case, what we have to do is, in the state space representation, you need to mention each and every possibility. You need to mention each and every possibility. So if you are making use of breadth first search, then you will go for the representation of all the possible ways. But if you are going for the depth first search, we are going to consider only one particular move and we will keep on going in that particular move only. That's why it is been named as a depth first search. Okay, depth first search, select one particular area and it will move in that particular line only. Okay, so it is not going to concentrate the other branch of the tree, we can say. So in this case, if you observe, so this is a given state. So our empty space is in this particular area. So how many possible choices are there? Either you can move top, down, left, or right. So as it is in the corner, we cannot make it top. Means we cannot apply the top rule. We cannot apply the right rule. Only 2 possibilities are there. One is either you can move right, or you can move left, or you can move down. So in the state space representation, or in the graphical representation, we are going to mention the 2 possibilities. So these are the 2 possibilities. What is that? Either you can move this 3 to this particular location, or you can move this 4 to top. So if you are moving 3 to right, then we can say that here this position is going to come next. Okay, so it is our initial state and it is going to become our current state. So if you are making this particular move, what is that? Moving the 4 to the top, then the possible state you are going to get is this. So again for this, again there will be 2 possibilities. Here there are 2 possibilities are there. 2 possibilities, or we can make use of 3 possibilities also in this, no problem. Why? Because you can move this 2 here, or you can move this 3 here, or you can move this 1 here. So if you neglect this 3, why? Because already you have moved 3 from this point to this point. If you neglect it, this, how many choices are there? We are having 2 possible choices. So we are going to keep on representing the graph in this particular way. So how much time we are going to continue? Means until and unless we reach to the desired state. Means for each and every move, we are going to check again the possible moves, available moves. Based upon that, we are going to represent the state space. If we are representing all the possible moves, then we can say that it is some kind of breadth first search technique representation. If you are considering only one particular move, and if you are moving in that way only, then we can say that it is some kind of depth first search representation. So like this, we need to understand how the breadth first search technique is used in order to identify the alternative solutions for a given problem. Coming to the depth first search, so how it will be? So to find a solution path, right? Solution path, I am representing it as solve from a given node. So what is that? N to some node. How it will be? If N is a goal node, then solve equal to N. So what is N here? N is the list of nodes. So what this list of nodes are telling means it is going to give you the path which we are making use in order to move from the given state to the desired state. Okay, so how this can be possible? How this can be possible means whenever a particular node, for example, if this is your given node, for example, node 1. Okay, so for each and every node, we are going to see whether there is any successor to this one or not. Means next node. So for example, if this is your next node and there is a path exists between these 2 nodes, then we can say that this is the, for example, 2 is the successor node of 1. So if this 2 is your desired state, then your list is going to have 1 comma 2. So we can say that this 1 comma 2 is going to give you the path which is showing us a direction moving from the given state to the desired solution. Okay, given state to the desired state, like that also we need concentrate. If there is a successor node, if you think it as n1, then there is a path, definitely. There is a path, right? So how that path we are going to represent means it will be like this in the prologue. Sol equal to n of sol 1. So in the earlier sessions of list we discussed the list of elements we are going to represent in the square brackets, and whenever you make use of this pipe symbol, it is called as the representation. This part is called as a head part of the list, and the other part is called as a tail part of the list. Okay, so what does it mean? If there is a solution, definitely that solution is going to be one of the node in that solution. It need to be understood like that. So this is going to translate in this particular way. What is that? Solve n comma in the given list of n. So when we can solve it means when there is a goal of n. If our goal node is n, then automatically we can say that we are going to get the list of those nodes. Okay, so this is the other kind of representation. What is that? Here in this case we are saying it as n comma n1, s of n comma n1. So what we are doing, we are trying to do the solving of this one. What is that? n1. What is n1 here? n1 is the successor node. See, every time we cannot say that the very next successor node will be the desired node. So in that case, what happens? We need to move like this. Maybe this may be our desired node. If these nodes are 1, 2, 3, so we are calling it as n1. This can be n2, and this can be n3. So in this case, what happens? In the list we are going to get n1 comma n2 comma n3, like that. So for these particular cases, this rule is going to be applicable. Okay, if you are this one will be applicable for these kind of things. We will try to understand more clearly. So in the 8 puzzle problem, we have discussed how this breadth first search is technique is used. When it comes to depth first search, we can say that it is also trying to give the alternatives in the state space by exploring each and every alternative. But we know that the depth first search is going to select one particular path, which is nothing but the deepest one. So the depth first algorithm is going to continue the search from the several nodes. It is going to search among the nodes by deciding to choose the deepest one. That's why if you see this diagram, it is very clear. Why? Because here for this particular node there are 2 possibilities, but at a time it is not considering the 2 possibilities. It will take one particular path, it will take one particular way, and it will keep on going. So what these 2 things will represent means the goal nodes. So in this case, what happened? We can say that there are 2 goal nodes, means there are 2 solutions available. But when you make use of depth first search, whenever the particular goal is reached, it is going to stop its search process. Okay, so the search process is going to be like this. Okay, so here whenever a particular depth is reached, it is going to perform the backtracking. Means the backtracking will be implemented and it will go back. So how we are going to represent means after representing the database, we are going to ask the question in this particular way. Solve a comma SOL. So what this SOL is going to do, it is going to trace. What is that? Trace the way. Way is nothing but the path. So in this case, the solution is going to have, if you represent in terms of a list, we can say that A comma B comma D comma H comma E comma I comma J, like this. Okay, so it will be like this. Okay, so this is just an example I am showing how the things will be represented. So we are going to get, okay, this may not be exact, but I am telling that the solution is going to get like this, which is nothing but a trace, means a path. path which is going to clearly show how the traversing has occurred from the given state. For example, this is the given state for us. Okay, given state, and this will be the desired state. So at the end we are going to get this kind of path. So hope you understood how this depth first search technique and breadth first search techniques are implemented while solving the AI problems. So we are going to see more examples how these various techniques and uninformed techniques and now informed techniques are going to be used in order to solve these AI problems in the coming sessions. Okay, so this is the textbook I have used in order to prepare this particular content. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.